Hello students, welcome to this now fifth lecture in algebra. Today we will be focusing on changing the subject of a formula, and this section starts on page 82 of your notes. We come across a lot of formulae in mathematics and in science, especially in physics, and quite often one is required to change the subject of a formula. Let's look at a very common one that all of us should know. C is equal to 2 pi r, and the value of pi is 22 over 7, which relates the circumference of a circle to its diameter. Circumference is equal to 2 pi r. Now suppose we were asked to make r the subject of the formula, so which means currently c is the subject of the formula, but we want to, it must be written as r equals something. So because this is on the right hand side, we will not change anything in the formula if we just swap these around. 2 pi r equals c, nothing has changed. I've done that because I want r to be on the left. Eventually I want r to be the subject of the formula, and because there's 2 pi here, I can get rid of the 2 pi by dividing there, but then I'm going to need to divide by 2 pi on that side as well, and I'll have r equals to, after these cancel out, r equals to c over 2 pi. So here I have the circumference, the formula for the circumference of a circle, with c being the subject of the formula. Here I also have the formula for the circumference of a circle, but r being the subject of the formula. So I've changed the subject of the formula for the circumference of a circle from c, the circumference, to r, the radius of a circle. Let's look at the, relating to the circle again. We have one which is a is equal to pi r squared, which is area is equal to pi r squared. Area is equal to pi 22 over 7 times the radius squared. And again, suppose I want to make r the subject of the formula, to read r equals something. So we transpose left to right. Pi r squared is equal to a. I just swap them around. I have not changed anything. And now I have to get rid of the pi, so divide both sides by pi, and the pi will cancel out here, and have r squared is equal to a over pi. And now I have an r squared, and to make that r, to drop the square, you have to pick up a square root on the other side, which is a over pi. Now you may wonder what happened here. When you drop a square, you pick up a square root. Now if you look at this more carefully, r squared is equal to a over pi. So to get rid of that, what I really need to do is multiply that by the power of half, which means I need to multiply that by the power of half as well, because 2 times half is 1, and then only I will get r. And then anything expressed to the power of half is actually a square root, so the square root of a over pi, and that's how we get this here. So say to drop a square, excuse me, we pick up a square root. The similar thing will apply to a cube. When you drop a cube, you pick up a cube root, and so on. So it's just a short form of doing what I've just done in more detail here. Let's look at another one. Number 3, volume is equal to 4 over 3 pi r cubed. Now that there is the formula for the volume of a sphere like a ball. So the volume is given by 4 over 3 pi r cubed, the radius cubed. Again, I want to make r the subject of the formula. And to make r the subject of the formula, I will need to transpose everything on this side. 4 over 3 pi r cubed is equal to v. Now, I will need to multiply by 3 and divide by 4 pi on this side, and do the same here. So I need to multiply by 3 and divide by 4 pi. So again, I need to multiply by 3 and divide by 4 pi. So what would happen here is that 3 will cancel and the 4 pi will cancel, and I'm left with pi r cubed. Sorry, the pi is out because we have now also cancelled the pi, is equal to 3v over 4 pi. And we have r cubed. So what we say, to drop the cube, we pick up a cube root, which is 3v over 4 pi, and drop the cube, you pick up a cube root. So now this is the formula for the volume of a sphere using r as the subject of the formula. This is the formula for the volume of a sphere using v as the subject of the formula. Right, so I've done 3 examples there using the same basic rules that we learned in the previous lesson. What's left for you to do is to now look at the exercise that appears on page 84 and go through that exercise. That